Hey, everybody. Thanks for joining on in. I'll be turning it on over to Okoye.
Since Mark 1 is saying he's not hearing any voice, I wonder how to it.
I think it's just an audio issue on Mark's line. I'll try to help him offline.
Okay. Welcome everybody to the second lesson of Web3. So we're still using the CryptoZombies, and we'll continue from where we left. And just since my screen is can't move the screen. Sorry, kind of a technical glitch. Okay, so still OffChain, and these are the social media links. And I mean, this is not going to make you a software engineer, like you know. This is the lesson we are using. CryptoZombies. Emeka Oko is my name, and so we're aiming to do Solidity and probably add some JavaScript to it. I mean, JavaScript library like Web3.js or Ether.js. So we're gonna move in straight to the lessons, and what happened? So we left off from chapter 7 of lesson 1. Sorry, I don't know what's happening to my internet now. Why?
Unfortunately, that's a VPN issue. Connection reset. Quite possibly, the VPN got disrupted. There you go.
Lessons. Ridiculous. It's showing chapter 1, but it's not showing me chapter. And it's not. I'm sorry, everybody. Just kind of network issue. Why?
Unfortunately, try switching your VPN. I think this is VPN related. The connection was reset. That's pretty indicative of a VPN, Great Firewall resetting the connection.
But I wonder why it's so big. Lesson number 2. Okay, I'm using Mozilla now.
Okay.
That will be better. Oh, sorry, everybody. And we start 7. So we left off at chapter 7, lesson 1. And hope you try to practice what we learned the other time. And so, okay, we've done this. So the last time we declared a function. So when you declare a function, you, just like JavaScript, you state function, declare the name of the function, and assign the parameters and the visibility, whether it's going to be public, private, internal, external. We'll talk about that later. And so, and remember, since it's strictly typed, even when you're declaring the parameter, you have to state the type of the variable you want to, the parameter you want to pick in, the type of the input. So for here, and this underscore name is referring to a string, okay? And if you're using if the parameter is going to be a string, an array, and some other operator, you need to specify if it is going to be stored in the memory or in the storage. So that's pretty easy. Let's move on to 8. Okay, so creating a struct think we've done this. Okay. Okay, so this very chapter is about creating structs. I think I did this the other day. And no. Okay, no. So let's move on. So here we created a struct. Okay, struct is like a complex kind of data type that can take in a combination of both string, boolean, and whatever it be, number, whether it's a unsigned integer or signed integer. So, but when you're doing the real world data, you may want to put this struct in an array, right? And we did something like that. We try to make a zombie array of struct. Okay, so this is a zombie array of struct, of type struct. Let's say you want to make an array of unsigned integer, okay? And you want to declare the visibility public, and let's say zombie IDs. So I guess that is pretty simple. This is an array. You know it's an array because it has this open and close bracket. And another thing, this array is a dynamic array because it doesn't have, it's not fixed. So as when you want an array that takes in only two inputs, you can define it like this. So we call this a fixed array. So that being said, this is a array of struct, of struct zombie. So here, what do they want us to do? They want us to make a kind of struct, and then, okay, here they make a struct and they made an array of struct. Okay, that's pretty cool. We've done something similar here. And okay, and now what they want to do is that they want to take in inputs for this array they've made. Okay, and then bear in mind where this lesson is going to. They actually want us to make a kind of array of zombies, okay, where let's say a user comes into, a user uses this DApp, okay, puts in a name, okay, when the user puts in a name, a DNA is generated for the zombie, and then we need to store this in a database where we have a name linked to the DNA, okay, so that's very important. And then this is how you actually create an array, create new structs, because here we just declared it. We declared a struct called zombie. We say we want to make an array of zombies, but we've not declared it for the first time. So here is the function to declare it. So remember, we made the function create zombie. Okay, what does this function takes in? It takes in two parameters, a string and a unit. So what it does is that when a user calls this function, we know a user is going to call it because it's public, like the visibility is public. Okay, that means anybody can call this function. And when they call this function with a name and a DNA, a zombie is created. So let's see how it goes. The exercise is fill in the function body so it creates new zombie and adds it to the zombie array. The name and DNA for the new zombie should come from the function arguments, okay? Comes from this argument. Let's do it in one line of code to keep everything clean. But that being said, let's look at what they've done here. So then you see that it's not even very hard if you've done JavaScript. Just the way you push in numbers to array, that's the same stuff you do here, okay? But now this is a struct, so you need to push it in like this. And let's do it anyway. Zombie, create a new zombie. zombies push. And then what are we pushing? We are pushing exploit. And then it takes in the name, it takes in this argument name and the DNA. So I think that's fairly simple. Remember your semicolon. So zombies, okay, you're trying to say, you want to push, just like JavaScript, you want to push this into the array. So you have to enclose it as zombie because this is a exploit. Okay, another simple way, another way that might be more intuitive. Let me show you another way that might be easier that might make this easier to understand, is to add something like this. Okay. And just take in whatever I said, like we're trying to add a exploit, right? So you just do the same thing, string, semicolon, unit, like here. Okay, you just got everything here, put it back here, unit. So I think this is pretty intuitive. So you're pushing a zombie into this, and the parameter is coming from here. Like the argument is coming from this input. But this is pretty long. Let's try to comment it out. So you comment the same way as you comment in JavaScript. But this is gonna yell at us because it's gonna yell at us because it's programmed in such a way that it's gonna pick whatever. It's not really a real editor. So let's try to finish this up. So very easy. Let's go very fast. Okay. So since we have very few, Ben, can you open up the chat so that we can make it more interactive, since there are not a lot of people that can ask questions?
I will certainly try. I think everybody can unmute themselves. They just have to.
Okay.
They just have to unmute if they want to. But let me.
Yeah, you can unmute yourself if you want. Since we have few, so it's not going to be a rowdy kind of question.
Keep it down, guys. Yeah, go ahead and ask questions, and anybody who wants can unmute themselves.
Yeah. Okay, so so now we've created this function, and let's see what they want to tell us. Okay, so here they're trying to say, like anytime you create a function, okay, you have to define the visibility of the function. Is it going to be public? That means, is anybody going to call this function? Okay, private means it cannot be. It's private. Nobody can call this function. Okay, and you can equally make the visibility to be internal. Internal means this function can only be called by, can only be called by a function on our contract. Okay, and there is another visibility, external, where another, like the name implies, another contract can call this function. Only another contract can call this function. So when you make a public visibility, it means anybody can call it. Although there's another way you can still make it, where you can put in some function modifiers where you restrict who calls it. Okay, like I can create. Okay, let's not go there. You can actually modify this, but let's go. Let me show you the implication of declaring a function public. Okay, since I declare this public, it means anybody can come in and create a zombie. This is a game we want to create. And declaring this public means anybody can come in and just put in this argument, put in a name and a DNA and create a zombie for himself. We don't want that. Okay, so we need to make this private. Now, this is what this lesson is trying to talk about. Okay, you can declare a function private, and you see what this function does. First of all, this is like an array of for unsigned integer. Okay, it's a fixed. It's a dynamic array because there's nothing there. And then, and now we call it. Okay, that will take me to another definition. Okay, any variable inside a function is actually a local variable. Okay, but if it is outside of a function, we call it a state variable. Okay, and somebody asked a question the other day about, so whenever we want to change this value, okay, it means we're changing state. That means we're changing something on the blockchain and we have to pay gas. We're making a transaction, we have to pay gas for it. And so back to where we are. So we need to make this private. So that's very easy, the easiest thing to do. And you know why we ought to make it private? Because we don't want anybody to keep on calling our zombie. And so that's all for this chapter. And I think that's pretty all for now. Said no. Modifier so is a private function. Don't forget the naming convention. Okay, so there is a naming convention for all these things. It's not really a must, if this were to be real IDE, I'm going to pass through, but there's a naming convention where when you want to name a private function, you are advised to just use underscore, okay, to put underscore CryptoZombie, just like this very argument here. You don't really need to put underscore. You can name it anything. You can leave it as name, DNA, still the same thing, but just for convention's sake, we add underscore onto it. Okay, so
it's a really good practice, because otherwise you'll end up accidentally making something public that you really never wanted to be public. And given the heightened security aspects of doing everything on the blockchain, it's really strongly encouraged to make sure you always use this naming convention of underscore and then the variable or function if it's private, because you could easily accidentally expose something that you didn't mean to expose.
Yeah.
Normally with other coding languages, we have a bit more flexibility around this because, well, the source code is usually not available and you're not getting attacked as much. It still is important in every language, whether it's public or private, but in Solidity or any blockchain programming, it's especially important because you can't fix it later and it's so sensitive.
Yeah. In fact, anyway, I wanted to say nobody does make this kind of mistake, but this mistake have been made, for a long time. Actually, what some people do is that they forget to put in the visibility. Okay, maybe because here when you declare a state variable, okay, the default, like we didn't declare the visibility, right? But the default is going to be private. Okay, and but for function is the opposite. The default is going to be public. So probably when you programming, because this is private, you might equally think that this will be private. So it's in fact it will be a good practice to even go back here, in my own opinion, write private so that
always
that
better to be explicit about all this stuff so you don't forget or accidentally make some mistake where you think you thought was private and it's not.
So this is blockchain security should be top notch. Thank you, Ben. So, well, I believe to allow me, it's going to say, this is primitive. So let's give Van.
Okay. Yeah, can.
Can I ask a question?
Yeah. You're welcome.
Okay. Now my question is a bit bizarre and it relates to settings inside machines that are controlled by computers. I've seen instances where the settings have changed apparently by themselves. So is that possible here?
No, not really, because when you do this, compile it, send it to the blockchain.
All right, and there's no way it could change for some other reason.
We seem to have lost the connection a bit. Your connection's a little unstable, but yes, one of the sorry, your connection's still unstable. Yeah. Yeah, one of the biggest benefits of blockchain is that it is immutable. Anything that you successfully post to the blockchain cannot be changed without you changing it. So that is one of the big benefits. I think
what you can change. I don't. Not really. No. Okay.
There you're back. Your connection's still a bit unstable.
Okay.
All right.
I better shut off the VPN. I think it will be better.
Yeah, I see you're on global mode in Clash. Did you try perhaps not putting it in global mode and go to GFW? Just a quick adjustment could help avoid. If you right click on Clash.
And okay.
Right click on the Clash icon on the taskbar.
Go to direct.
Yeah, no, not direct, but do rule. See rule. See proxy mode. Rule. 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 Do that.
Rule. Okay. Here, correct. Right?
Yeah, it'll default then to only then send things that need to be sent to the VPN. Give that a shot.
Oh, that's great. Thank you.
We'll talk after class. I'll give you some more advice.
Actually, I think I got Clash recently. My main VPN is Shack. I'm familiar with that very well, but somebody advised me to get this the other day. Okay, so let's go deep into functions. So more on functions. What do they want us to talk about here? They want to talk about return. So this function, okay, it doesn't return anything. So what it does is that it takes these parameters, the name, DNA, creates a zombie for you, okay? And it pushes it into this array. But you may want a function that displays something, that returns something. So here we're going to say it, okay? A good example is here. This is, I want to know if Santiago, team, are they here? Santiago team. Okay, Hadi, are you here? Okay, anyway, let me.
Yeah, I'm here.
Okay, I mean, so you know this is a function, right? In Solidity.
Yeah,
and
sure.
Yeah, so what is this? Sorry, just want to know if you followed for other one. Like this is state variable.
It's a string.
Okay, and it takes this, right?
Yeah.
And you know the string because it's written the type string, right? Okay.
Yeah.
So let's go back to the next part, the function. Is this function a private of private visibility, internal, external? What visibility does it have? Public, right?
That's a public function, yeah.
So anybody can call this function. And something we didn't learn here, this function is going to return a string. Okay, so we use the keyword returns, and then you have to state the type, string memory. Okay, memory means it's not going to be stored on the blockchain. So after the function gets executed, everything gets wiped off. Okay, so this is what it's going to return. So when we click this function, say hello, it is going to fetch this state variable, okay, greetings, and return it. Very easy. But even at that, I think they're going to introduce it in the next time. So we really have to state if this function is going to, if it is a view function, a pure function, and okay, it's here. Wow. Okay. So function modifier. Anyway, function modifier means you really have to state what the function does. Like this very function, okay, you see that it does nothing. It doesn't change anything, right? This say hello function, we call it, it just copies whatever is in greeting, okay, variable, and returns it. So is basically what we call the view function. So what do we mean by the view function? It views the blockchain. Okay, that's it. There's another type that is called a pure. Pure means it doesn't even view the blockchain. I think they should have an example here. Okay, very good. So this is one example of a pure function. This function is called multiply. Okay, we know it's private function, of private visibility. And what does it do? To input A and B, okay? And then it multiplies A and B. So it doesn't really view anything on the blockchain. It doesn't view anything on doesn't view our state variable. It doesn't call other functions, nothing. Okay, it doesn't change the state of the blockchain. So we should declare it as pure. Okay, and for this, the say hello function, it only viewed what is on our state variable, and we should declare it as view. Okay, view function. So that's a view. And so let's go back to so here, this very function, you already know what it's going to be. It should be okay. So if it is going to change state, you don't need to put in anything. Okay, you just leave it like that. It's going to be default like that. So let's create another function according to this. So create a private function. Okay, start here. This ID is tricky, so you have to be careful. Just start below what is when they say start here, start above and hit an enter key. So let's create a private function called generate random DNA. Okay, so here is where we're going to generate a random DNA. Okay, and remember, our zombie is going to have 16-digit DNA. Okay, remember the start. We want a zombie that has 16-digit DNA. So let's write a function. Function create random DNA. Okay, and then what does it take in? It's going to take in one parameter. Okay, what's the parameter? It's the parameter is underscore str. Okay, but of what type? It's of type string. Very good. And then what is the visibility? Is it going to be can everybody call this function? No, nobody. We don't want anybody to call this function. Not even, we want it to be private. Okay, so we call it private function. Then you ask yourself, what is this function going to change state or not? If it is going to change state, when I mean change state, is it going to change any of these state variables? I told you a variable that is not inside a function is a state variable. The ones inside, just declared only inside the function, is a local variable. Okay. Then we have what we call the global variables. Global variables can be like in Python, which will I give an example of on JavaScript? Just like an internal defined function, okay, or variable, like in a very popular one in this in Solidity is message.sender. Message.sender is a popular global variable. So what it does is that any message.sender simply gets the user, anybody that is using or that is clicking on this contract gets the Ethereum address or the wallet address. So let's continue with this. Do not forget to set the data location of string to memory. Very good. I think I did it. Oh, sorry. Here. String memory. You know why is memory and not storage? Because you're not going to use it after now. So let's move. So the function will view some of our contrast variable, but not modifying them. So let's mark it as view. So now you know why it's view. It's going to just look at what is in the contract. It's not going to modify our state variable. So it's not going to change state. So we call it view. We make it of visibility view, and that's all. they said leave the function body empty. Then let's go to the next. I may not, I may equally be skipping the show answers because, you know, for this, maybe if you don't put in something exactly where it wants it, it's gonna yell at you. But just for the sake of people that will be using this to practice, let's see how it works. So you can either try again, okay, if you think you have an error, or you show answer. So when you do show answer, you can see where the problem is from. You can say there's a problem here. Probably it doesn't want us to leave any line. Okay. And returns. Did I see everything?
It also wanted us to push.
Wanted us to do what? Sorry. Sorry, let me.
It wants us
create
to
a private function.
return.
Yeah, it will take. Did it study here? I didn't see any.
I didn't see it either. I missed it. But it wants us to return.
Yeah, it wants us to return.
Where did it say that?
Okay.
Well,
it didn't say that, but no problem.
Can't hurt to include a return type.
Yeah. Anyway, let's return. So this function is going to return the DNA, and this DNA is an unsigned integer. Okay.
As a best practice, just like the private, versus public, if you are expecting to return something, it's always best to include what it's expected to return. Yeah.
So you should return, and remember, sometimes you might fall into problems writing return. It's actually returns, okay? But whatever you're going to return, you call it with return. A good example is this. So whatever you're going to return inside the function, you use return, but for when you're defining it, you define it with returns. And then you state the type. So if it is going to be an array, you know what to do. You just include something like this. So you're returning an array. But here we are returning this. So I didn't check the answer. Oh, you deleted it. So don't worry, I won't waste time. Let's go to the next one. Okay, let's say, okay, you made a function that takes into inputs. That takes into variable. Let's say this has unit 8 and this has unit 16, okay? And you multiplied these two state variables, and then you really want to return it, okay? Let's say we made this function to be DNA digits. That's very fast now. Okay, and you say return. So, okay, so when we're going to return, okay, you might actually fall into a problem here because this is a unit 256, okay, whereas our input for this is unit 8 and unit 16. So what we do is that we typecast, okay, we turn them to whatever variable they are to whatever we want to display. And so we're going to say it here. We're going to say it in this example. So here they say we want our generate DNA function to display a random unit. And then, but to be frank and honest, when you're doing Solidity, in fact, blockchain, it's better you get anything you want to be random off-chain, okay? Just use an oracle to get it. But this, I like the way they put it. They said a semi-random number. So there is this hash function in Solidity that is called Kcash 256. So it's like, if you know the SHA-3. So what it does is that you give it an input and it generates a 256-bit hexadecimal number. And but don't always use it. I mean, for if you want to use it for something that maybe you want to generate, you're making a guess game. When you use this, people can break it easily. So let's see how we can generate a semi-random number using this Kcash 256. And we have to remember that this Kcash, sorry, my pronunciation of this might be wrong. So what you do is that you first of all have to type whatever you're doing to bytes, because it doesn't take unit or whatsoever, it doesn't take string per se. So even though you've input a string, you need to convert it to bytes. And in Solidity, this is like the code they use for it. And let's quickly go and solve the problem. Okay, but before then, let's look at this. This is like the example I just gave now. This is a state variable A, okay, of type unit 8, and this is of type unit 256, okay? I'm here in case you're looking for where my mouse is. So we want to make another state variable called C, and we want to multiply A by B, okay? So you see it's going to throw an error because they are not of the same type. This is of type unit 8, and this is of type unit 256. So how do we solve the problem? You typecast. So here they want C to be of type unit 8. So what it is that they typecast B. Okay, so typecasting B means that B will be a unit 8 and A will be a unit 8. So your output is going to be the same, unit 8. So it's fairly easy. Okay, so let's solve the problem. They say fill in the body of our generate random DNA. Okay, so want to fill in the body. So what they want to do is that they want to generate a random DNA. So probably when the user puts in a name, okay, they will take the user's name to generate, to generate a DNA. And also they say in the first line of code, we take this hash-tree function, and I will be fast now. Time is not our sign. And sorry, let me just copy from here so that it'll be easy for me. I've explained what it means. So we wanna use this hash function, okay, to turn a string to a 256 byte hexadecimal number. Okay, but first of all, we need to typecast it to bytes. So that's where all this thing came up. So this is going to take this parameter string. Okay, so it's going to take in this. Okay, so that is fairly easy. And let's follow the question. To generate a pseudo typecast as a unit, and finally store the result in a unit called rand. Okay, so let's typecast this as a unit. Unit 256. I can write 256 or I leave it, okay? But let me leave it here. So simply, you know what this function does? It's going to get this, okay? It's going to hash this number. First of all, here, sorry, this is going to convert this input to a type of byte, and then this is going to hash it and get whatever figure is going to get, and then we typecast it to this, to 256 unit. So the next one is to give it a name rand, and then what is rand going to be? Rand is going to be of type unit. Okay, and then they said we want our DNA to, I'm here now, I'm here. We want our DNA to only be 6 digits long Okay. So the second, okay. These guys are smart. So what they are doing here is that they take in rand. I'll show you what they did here. Just to be fast. Remember when we started, we made a DNA digit, okay, state variable called DNA J16 DNA module. So why they made this is that they thought of how to create a 16-digit number, okay? So what they thought about is that when we get any number and find the modulus, okay, of that number using 10 raised to power 16, okay? Like when we get that number and divide it by 10 raised to power of 16, okay? We are going to have a 16-digit number as our result, you know? So that's the brain they use there, which is beautiful.
This is a pretty common technique in blockchain, and I think it's important to kind of pause here and talk about why we're doing this, because it is very confusing to anybody who's new. Normally, when you're programming, you would have a random number generator. Random numbers are necessary all the time when making applications, and normally we just use the computer's random number generator. The problem with random is it's random, it's unpredictable. And when you're making a blockchain, everything must be predictable. Everything must be calculated by a distributed network of computers in the exact same way. So nothing's actually random. Everything is very much deterministic. So now you have a challenge. If your application needs to generate something random, like a random zombie with different eye colors and hair and whatnot, how do you generate something random when nothing can be random? Well, the thing that's random is actually then you can get user input. So when you get user input, you don't know what the user is going to send you. So that string that we're passing on into this generate random DNA is our randomness. It is something that we don't know what it is. But although it's random, once it's into the blockchain, the message itself, then it's deterministic. Everybody who evaluates this function will come up with the exact same answer. Even though it was random of what was going in, what comes out will be completely expected. So the trick that's being used here is, well, how do you make a random DNA off of a string? The DNA itself has to be this, 16-digit long integer. So what ends up having to happen is we take the string, we convert it back into bytes. Now we have digits, and then you can hash those digits. We can then cast that into an integer, and then we can use the modulus to extract out just 16 of them. So modulus, if you remember back to algebra, you may not remember this. So when you divide something, if I say 4 divided by 2, it divides cleanly into the number 2, and then there's a remainder of nothing. There's nothing remainder. But if I said 3 divided by 2, well, 2 can fit into 3 one time, but it didn't do so cleanly. What's left over is the modulus. So we can kind of use this clever bit of math as a way of extracting information on out into something like being able to set a DNA. It allows us then to be able to cleanly extract out exactly how much information we want. So we use the string to get us some bytes, which we cast into a hash function, which we put into a integer, and then we divide it by a modulus, which allows us to extract out exactly the amount of information we need to get randomly, which is this DNA. It's a bit much to wrap your head around, but you can use this trick a lot in the blockchain because you won't have random numbers, and you will often need to be able to extract out exact amounts of information. I hope that makes sense, and I hope I said it correctly.
Yeah. Your explanation was very good. Very good. So I mean, when you're going to go back to redo these codes, okay, you will understand his explanations better in case you didn't understand it now. So here we're running out of time. So chapter 12. So let's put it together, okay? Don't worry, we're gonna run through the code again so that you get whatsoever thing that happened. So here, they want us to put everything together. They said, create a public function named create_random_zombie, okay? Let's do it. I would have loved somebody else to do it, but we don't have time. Let's do it, okay? Function random zombie, create random zombie. And it's gonna take one parameter. And what is it? It's gonna be a string. So when you declare it as memory or storage and name. Okay, this is the parameter name and it's of type string and we're storing it in the memory. So we don't need it after this function. And they say, note, declare this function public, just as you declared. Okay, so this is a public. This is a function of public visibility. Is it returning anything? They didn't say such. So let's continue with the code. And they say the first line of this function, I'm here because the first line of this function, we run this DNA generate. Okay, you're going to understand it from here now, and it's going to take in these parameters. So random. So what this function is going to do is, okay, when you hit on this function is going to call this other function, and you see it's going to call this function, and then it's going to take in whatever you put in here. That's the name, okay, and what is happening to my mouse? And it's going to use it to generate the zombie DNA, okay? And they said, and store it in a unit named random. Sorry, my mouse, I don't know. Okay, just got my. Okay, sorry, technical issue. Okay, so we want to call this function, okay, and then we give it the name, this random, and then remember the type of type. I'm actually typing from right to left, so that you can still wrap it all around. So this calls this other function and then puts it into rand. And what else? Let's see the second line. The second line should run the create zombie function and pass in name and gradient. Okay, so very fast. First, this is going to run this. This is going to call this function again, and then should take in two parameters. Remember our create zombie, if it is going to call this function, the create zombie function takes in two inputs, which is name and DNA. So let's see. So it's going to take in name and rand DNA. And so number 4, the solution should be 4 lines of code, including the closing function. So remember to add your semicolon, and that's all. So let's see what this function actually does, okay? This is a public function. Anybody can call it. So when the user calls it per se, the user puts in a name, okay? It takes in this name, okay? Uses this name to generate a DNA. So basically what it does is that it calls this other function that we've created, this function, okay? It calls this function with this name. Can you see the parameter? It calls this function with this same parameter name. And then just like Ben has explained, it's going to use it, convert it to byte, hash it, and then get a hash, convert it back to unit, okay? And then use it to generate a 16-digit number, okay? And then after it must have done that, this function it's going to call another second function. That's the create zombie. Okay, this is it. It's going to call this function with name, and the DNA is generated. It's going to call it with that DNA we generated, which we've stored in rand DNA. Okay, so that's pretty cool. And so the user ends up having a DNA. Okay, we have the call of this function, and a zombie is created. Okay, so now that a zombie is created, what happens? You need the front end to know what happens. Okay, what has happened? A very good example. I think somebody asked this question the other day. Let's say you have 5 dice, okay, or 5 USDT, and you send 3 to your friend. Okay, how does the front end know that you already sent out 3 and it changes back from 5 to 2? Okay, so and it's just a simple thing. Because usually, if something happens that way, you need to refresh your browser. But here in the blockchain, in Solidity, there's something called events. Okay, so events actually get fired when maybe a function is called. So let's say we call. Okay, let's go back to the DAI USDT example where you send out 3 USDT to your friend. Okay, and you have 2 remaining. Okay, so what actually may have occurred at the background is that the function also fires an event. Okay, this event actually tells your front end about what has happened, so that your front end updates it, okay, automatically. And so we'll be seeing how to fire events. So here now a user called this function with a name, and we saw how this name input or parameter was used to generate a DNA, and that DNA with the name was used to create a zombie. So we need to fire it, to tell the front end that something has happened. So we're gonna put an event there. So here, usually we declare events, like you can actually declare it anywhere, but here it's pretty cool. So let's declare an event. So I think it is good to look at this very example. So this very event is called integers added. So it takes in 3 parameters, X, Y, and results. Okay, and just like you have to state the type. Then it's pretty easy. So what happens is that when you call this function add, it takes these 2 numbers, okay, X and Y, okay, and adds it together, and then the result is going to emit it. That's we call it fire. It's going to fire the event. This emit function. This emit is going to fire this event. Okay. So you see, when you write emit fires an event. So when you call an emit, okay, you put in the name of the event, and then you put in the corresponding inputs. Just like whatever X is, you put it in here. Whatever Y is, okay, you put it in here, and so on and so forth. And this function also returns, even though it fires an event, it also returns, a unit. So this is a pretty cool example. Let's use it to solve what they've told us. I think this will be the last one before we close. So now we've created an event. Oh, sorry, wrong planet. So let's create an event, new zombie. And then what is it going to have? It's going to have, my mouse is kind of distorted. So let me be fast. We're going to have a zombie ID. Unit type. And sorry, I haven't done. This is not playing out fine. Okay. And then it's going to take another. It's going to take this name. Okay. Trying to be fast. going to be a string. So this will be last stuff we're going to do now. And then it's going to fire the DNA. Okay. DNA is an assignment to DNA. Just put it now. So here we emit the event. Remember to put your semicolon. Let me get it here so that you see what we're doing. Let me get the event here, and let's fire it. So you fire by using the keyword emit, and then new zombie. What are you firing? You're firing a new zombie. So when you call this function, it's going to fire this event, and then what's the zombie ID? We don't have any zombie ID yet. Name DNA. So let's go there and see what they said about the zombie ID. It's already 8 p.m., but let's just finish this line. I think that's the end of it. Practically wiped off what we did. Okay, no problem.
It's a hard jump for any beginners in the class to go from just introductory JavaScript to what we're doing here. So do take the time to kind of decompose what is going on in those random functions. I know it's a stretch, but that's what everybody goes through when you start learning programming. Is you have to learn these tricks. Some of these tricks are kind of unique to blockchain. Normally we would just use a random number generator, and somebody would push a button and would use the random number generator on the computer to just, well, generate the random zombie. Since we can't do that, we have to kind of make these clever tricks, and then you learn them as you go along, because they become repeatable patterns that are seen in a lot of different type of applications on blockchains.
Okay, so we want to make. So what is what they want us to do? Okay, is that anytime we create a zombie, okay, we give it an ID. Okay, and the trick is you give it an ID. Okay, and the trick is that when you push something to an array, okay, it's going to return the length of the array. Okay, but you know how array works. I believe most of you know JavaScript. Okay, so if an array is in position 2, so this first array, though it's in position 1, the index is 0. Okay, so when you want to grab whatever is in here, that's when you want to grab number 1, you use the index 0. So how do we grab index 0? You simply subtract by 1. Okay, so this is how they want to know the index of whatever zombie you're pushing into the array, and they want to use it as the ID of that very zombie. So it's very clever. You create a zombie, you put in a name, okay? You push in a name here as a user. It generates a random DNA, okay? And it creates a zombie, right? And then why pushing it into the array, it generates an ID for it, and you saw how we generated it. I think this will be somehow tricky. For me, I would have said simply use zombies.length. It's kind of intuitive, okay? That's length, okay? So it's still the same like JavaScript. Zombie.length gives you the length of the array, and -1, okay? This will be easier to use. Okay, but let's just do what they did. I think maybe in modern, I'm not sure if this is going to work in maybe Solidity version, the recent ones, but I will still check up. So this is how they want to generate the zombie ID. Okay, in a bit we'll be off, and I think that's that. So they said modify the create zombie function, blah blah blah. So here we push this, and we get the ID, so you can use this in the zombie event. Very good. Okay, so now we've created an ID, zombie ID, and it's a unit and 256. So let's go back and declare what we declared before. Sorry, it went off. So we want to declare an event, and we want to call this event, what's the name of this event? New zombie. So whenever we create new zombie, we want our front end to know that we've created a new zombie. And what is this zombie going to have? It's going to have, it's going to pick up, it's going to send off the zombie ID. It's going to send off the name of the ID. Okay, it's going to update it. It's going to send it to the front end and DNA. And remember, so when you start doing these things, you won't do it the way I'm doing. You just type in the type first. But I just did it this way so that you can remember. Okay, so but how do we call this event? We just declared an event, new zombie. How do we call it? Here, okay, when this happens, when this zombie ID is created, okay, we want to fire this event. How do you fire an event? You use emit, okay? The emit keyword. Let me get this here so that to be clearer. You use the emit keyword, and you simply call the name of the event. And then you release this number as this, okay? So zombie ID here, we want to represent zombie ID as this ID. Okay, we already created the zombie ID called ID. Just 1 minute and we'll be done. And what else is it going to pick? The name. What's the name? We use this parameter underscore name. Comma. And then the next one is what? Here, we're here, right? What else does this event entail? It wants us to put in a DNA, which is a unit, 256. Do we have a DNA? Yes, here, this input. Here's the DNA. And remember to add your semicolon, and that's all. So just right. Okay, so I think everything here is clear enough. So let's just go back. We created a contract in 3 minutes we'll be done, okay? We created a contract called here, I'm here, created a contract called Zombie Factory, okay? What this Zombie Factory does is that it takes in, there's a function called here, create zombie, okay? So what create zombie does is that it takes in a name, okay? And uses it to generate a DNA for the zombie and uses, yeah. So how does it generate a DNA? It calls another function. Can you see it? Calls another function, generate random DNA. And this is the function here. It calls this function, and this function is a private function, right? That means it cannot be called by somebody from outside. So it calls this function and it uses the same name, okay, as an input to kind of do some abracadabra, okay? Hash, first of all, it hashes it and then uses the modulus function to generate a 16-digit number. So the second part of this create function, create random zombie DNA, also calls another function, and this is the function, okay? You can see this function is private, so nobody can call this function from the outside. So it calls this function and it uses it to generate the zombie ID, okay? And then when it has generated it, it emits. It emits, it fires the event. It fires this event, okay, to tell the front end that we've created a new zombie with an ID, name, and DNA. So you can see in this very function, this very function is going to change state. That means you can see it's changing the state of the blockchain, okay, changing the state of this array, okay? So here, when you call this function, you're going to pay gas because it's actually a transaction. So that's why we did not declare the visibility as neither view nor pure. Okay, so we left it like that because it's going to change state. So I think we expect your questions on Discord. We've overshot by 9 minutes. And but I'm so glad we still have like mapping and yeah, I think mapping and one other one, and that will be all for the introduction. And you know, when we start moving, when we move into the next one, it will be so smooth. Okay, so don't worry about if you're very confused. Just go back and recode this. You know, you understand and read what read the text in the other part of the code, and it will be very smooth. Okay.
Okay. Thank you, brother.
Thanks, everybody.
Thanks, everybody.